Hello, everybody. It's the Crazy Math Nerd here for another installment of doing fun calculus. So, on the screen, you see the title of this is called Going Backwards with the Derivative. That's right. Everything we've done for the first 3 or 4 months of our career in AP Calculus, we're now going to be asked to go backwards. It's just crazy, but it's what we're going to do. So, when we do this endeavor, what we're going to do is we're going to be asked, find a fun color, we're going to be asked, we're going to be given the answer, like of the derivative. And what we want to do is we want to find out who do you take the derivative of and get cosine x. So when someone gives you the derivative and wants the y, that's what they're asking. So let me ask myself, who do I take the derivative of and get cosine? Well, we all know that's sine, right? Sine x. But what if somebody came and said, well, I think the answer is sine x plus 4. And I had another person come up and go, well, I think it's sine x minus 1,429. Are they right? Well, what's so cool about this new thing that we're doing is that we can actually take the derivative of all these answers. And if we give the derivative given, then we are correct. So if I take the derivative of sine, do I get cosine? Yes, I do. If I take the derivative of sine x plus 4, well, derivative of sine is cosine. The derivative of 4 is 0, so that works too. And if I take the derivative of the sine minus this crazy number I just made up, that also gives you cosine, doesn't it? It does. So all of these would be a fine answer. So if you are finding the function that you would take the derivative of and get something, you always have to consider that there could be another number right there. Like in my first answer, I didn't put a number. So, but there could be. So in order for us to give the best answer we can, what we're going to do is we're going to put a kind of a placeholder for that unknown quantity that could be there, and that's called c plus c. And that's what we do because there could be something there. Okay, so this variable is standing for some number that could be there that if we take the derivative, it would not show up in the derivative. All right. So let's look at this next little problem. It says the derivative is 3x squared. And I think to myself, who do I take the derivative of and get 3x squared? And I'm thinking, well, that's surely x cubed, isn't it? I think so. Yeah. So x cubed, but don't forget, there could be some weird number, so we're going to say plus c. And how do we know if we're correct? This is the coolest thing about what we're doing. If you want to know if you're right, take the derivative of your answer that I put in red. And if I don't get the problem I was posed in the first place, I'm wrong. You just know immediately. So if I take the derivative of that, if I just did like a little y prime, I'm thinking, right? It's my thinking cloud. I'm thinking the derivative of that is 3, take your power down, subtract a power, and the derivative of c, no matter what the number is, because c is standing for some number, 0. Is that what I started with? Well, look, it is. So that means that I am correct in my finding my y. All right, let's move up. We're going to get a little crazy and go to E-land here. So here's the question. The derivative is 3e to the x. I'm given that. This is kind of like playing Jeopardy. I've been given the answer and I have to find the function that if I do take the derivative, I get that. So the question always is, when I'm posed with this situation, who do you take the derivative of and get this? Well, I don't need the x. It comes from e to the x, right? And so I know that that's part of the answer. I'm not really sure what to do with that 3. Let me think about it. Let me think. Let's get a cloud going here. If I want to guess that y is equal to e to the x just by itself, and I took the derivative, I wouldn't get that 3. But what if I put a 3 there? When we take the derivative of functions like this, doesn't the constant just go along with our differentiation process? Yeah. So if I put a 3 right there, and don't forget our little number that could be there, our little constant, that's what we call that, our little constant. Then if I do take the derivative of this, I would get, the constant would stay there, so 3 e to the x, and then plus 0, which would give me that derivative. So I know that that is correct. So you just have to think through all the patterns that we did in the first semester to kind of figure out what you're going to do. And so I normally start with a thought, and then I might add or subtract to that thought depending on what I need to actually get that derivative. Oh, let's look at this one. Ooh, there's somebody in the denominator. So I need to think about it. Self, who do I take the derivative of, and that derivative makes me put something in the bottom? And I'm thinking, you know, that natural log guy, he does that because when you take the derivative of natural log, you get 1 over x, right? So what if instead of x, I had, I need to make my cloud bigger. I'm thinking, ooh, and it went away. Okay, let's make our cloud really big. Come on, cloud, here we go. Make our cloud really big. So what if it were y equals the natural log of x plus 4? Would that throw that x plus 4 in the bottom? Well, you know what? I think it would. I think it would. I do. So that'd be 1 over x plus 4. And you know, when we did the derivatives before, we went 1 over the stuff, whatever it is, times the derivative of the stuff, but that would just be 1 in that case. So if you have anything on the bottom, there is a very sneaky suspicion that it came from a natural log situation. Not all the time, but many times that's going to happen. So I believe the answer to this is natural log of x plus 4. Don't forget that constant, because it could be there. I don't know, it may not. And we're going to talk about how could we find this, or what are we going to do with it later, but we got to make sure it's there, because it could be.